Hello and welcome to this video. In this video we're going to talk about resistors. So we're going to look at how do resistors act when we put them in series and in parallel. We've already looked at how the current and the potential will act, but how will the overall resistance of a circuit change if we were to put resistors in series and in parallel with each other, and then how would we calculate the total resistance of a circuit. And we're going to have a go at a particularly tricky example of this. So in general, if we had a series circuit, so this is going to be let's start in series because this is going to be much easier. If we have a series circuit and then we put some resistors in, the whole idea of these resistors is that what's happening inside the resistor is essentially just a metal lattice. Okay, so it has a regular arrangement of metal ions surrounded by a sea of delocalized electrons. What's happening is, as soon as we have this battery applying some potential, all of these electrons get accelerated around this around the circuit, and then when they come through, they might collide with one of these ions, then causing the current to slow down, because we're basically saying that we're having less electrons transferred per second because we've slowed some down, so not as many are moving as quickly. So this is what a resistor on the inside looks like, and they act as resistors because of these collisions. Now if we continue to add, so let's say this resistance has a resistor, this resistor has a resistance R1, R2 and R3. If we are just going to add them together, we know the possibility of their collisions is going to continue to increase. Okay, and the way it increases is that the total resistance is just going to be the linear sum of these resistances. Now, it doesn't have to be limited to 3. It can continue on. We can just keep adding resistors in series until we eventually get to infinitely high resistances because of an infinite amount of resistors. Okay, so these are pretty straightforward, right? It makes sense because we are simply just adding together a linear array of resistances, and by doing this we're increasing the probability of these collisions. Now in parallel it gets a little bit more complicated. So this equation here is in your formula sheet, so you won't have to memorize this, even though it's really easy. But in parallel, if we think about the probability of the collisions, we're actually providing more options for the electrons to take. Okay, so I'm just going to do 2 here, but you could go to 3 or 4 or infinite, however many you like. Let's say this has resistance R1 and this has R2. The electrons that come down here, we've already said are going to split, so we'll get some through R1 and some through R2. What this means is that the total number of collisions isn't actually going to be as much as if they were in series with each other, because we can only have the electrons colliding inside here or inside here, but not in both as they would if they were in series. Because in series they would have to collide in the first one and then continue to collide in the second one. In this case they can only do one or the other. Okay, and so our equation for this is that actually these are reciprocal additions. So 1 over the total resistance is going to be 1 over R1 plus 1 over R2 plus 1 over R3 plus so on. Okay, this is how we're going to add resistors in parallel. Okay, and we could continue on with this forever essentially. What this implies though is that if we add, so adding resistors in series is going to increase the resistance. So adding resistors in series means that overall we're increasing the resistance of the circuit. Okay, that's because RT is our total resistance of the whole circuit, and if we keep adding more of them, we're going to keep basically increasing, because our equation for the series is RT is equal to R1 plus R2 plus R3 plus so on. So if we keep adding more resistances, RT is just going to keep increasing. Whereas adding resistors in parallel is actually going to decrease. So it decreases the resistance of the circuit. Okay, and the reason it does that is because overall we have less collisions than if we were to put them in series. So our resistance is going to be either this or this, and so overall we're actually going to end up with a much lower resistance if we put the two things in parallel to each other. This is an important thing here, because they can sometimes ask you in questions. They might give you just a collection of resistors and their resistances and say what would be the smallest possible resistance you could make. And the smallest possible resistance you could make would be to take the two smallest resistors and put them in parallel with each other. If you wanted to do the biggest possible resistance, you'd take the two biggest resistors and put them in series with each other. So now let's have a go at calculating the total resistance of a circuit. I'm not going to do one that is just purely series or just purely parallel, because this isn't really going to be too much of a challenge. We're going to try and combine them and we'll see how that works. So let's call this example 1. Okay, so our example, let's take a circuit where we're going to have two resistors here, and both of these resistors are going to be in parallel with a third resistor here. Okay, all of these resistances have a resistance R, so they're identical resistors. In your exam, they might give you specific numbers to work with. I'm just going to do it algebraically. So what we're trying to work out is what is the total resistance of this circuit, given that we have them in this state and they all have the same resistance. So what we know is that these two resistors here are actually in series with each other, because the electrons have to pass through both of these things. So these two are actually in series, which means the total resistance of this line, let me call this line A and this line B. So the total resistance of line A is just going to be 2R, okay, because we just have one resistance 2 times, so we get 2R. But then all of RA is in parallel with RB, so we can say that 1 over the R total is going to be 1 over the 2R, so this whole line here, plus 1 over R, which is just this line here, which is just that. Okay, now again we'd have to be algebraic, so if we want this to be over 2R, we have to multiply the top and bottom by 2. Then we can add these together and we'll see that 1 over the total resistance is just 3 over 2R, and now this is the reciprocal of the total resistance, so the total resistance is going to be 2R over 3 ohms. Okay, so this is our first example. Hopefully that makes sense. It's nothing too complicated, but you could take this and do a much more difficult example. Let's do one final example, something that will be a slightly bit different to this. In your exam, they're not going to get much more complicated than this, but you could go off and draw whatever circuit you like, and you should be able to work out its resistance using these. But let's have a go at example 2. So example 2 is a very, very common setup in exam questions. They will usually have a battery, and then this will split off into 2 resistors, and then have another resistor here. Okay, if I wanted to be mean, I could also put another resistor in parallel here, but I'm going to try and keep things a little bit nice for this. You could go home and then have a go at those and see what you could come up with. I'm going to again say that all of these things have identical resistances. Again, this probably won't happen in your exam, or maybe it will, but it's probably going to give you more numerical values rather than algebraic. But again, let's work out the total resistance. Okay, so what we need to know here, I'm going to call this whole parallel combination here A, and this resistor by itself is going to be B. Okay, now naming these A and B is not something you have to do. I'm just doing it here to show that I'm going to work out the total resistance of A first and then just add it to B. Now the total resistance of A, so 1 over RA, is just 1 over R. So this resistor here is in parallel with this resistor, so plus 1 over R. What you're going to find then is that 1 over RA is equal to 2 over R, and therefore RA is equal to R over 2. Now this is actually a very interesting result. It means that if we ever put any two resistors that are identical in parallel with each other, the total combination of those is actually going to be half of one of those resistances. So for example, if R was 5, so if instead of R here we had 5 ohms on the top and then 5 ohms on the bottom, the total resistance of this is just going to be 5 over 2, so 2.5 ohms. Okay, this is just kind of like a little bit of a life hack really, to try and make these calculations a little bit easier. If you can spot that, it will definitely help you out. And then the total resistance of this is going to be adding A to B, because these two things are in series with each other, so we can just take R over 2 and then plus R. But again, if we're trying to add fractions algebraically, this needs to be 2R over 2, and therefore R total is just going to be 3R over 2 ohms. Okay, so hopefully all of this makes sense. These two equations that you'll need to know are in your formula sheet, so you don't have to memorize them. I would recommend drawing out any circuit that you like. Just have a go at working out its resistance as a bit of practice. Put as many things in parallel and as many things in series as you want, and thank you for watching.